What's up my people and welcome to another video in Walrus Code. Infrastructure as code is amazing guys, every developer should know a little bit about this as more and more systems deployed in the cloud are being described as code. When you describe a whole system, a whole infrastructure in code, you know exactly every part of it and you know whenever there are extra parts that are not supposed to be in the system or whenever you are lacking some of them. It may happen, for example, that someone in your team accidentally changed something in your infrastructure manually without even communicating it to the team, and then without infrastructure as code you cannot easily track those changes. Another cool benefit to it is as you are using code to describe your whole infrastructure, your whole system, you may use Git as well, this source code management tool, in order to track down history of changes to your infrastructure. But one of the coolest features of using infrastructure as code is that you get to automatize the creation of huge complex architectures or systems in the cloud. This allows us to easily replicate huge systems in just a couple of clicks. Nowadays there are many tools to implement infrastructure as code. One of the most popular ones is Terraform. On the other hand, AWS has its own solution called CloudFormation, but CloudFormation may become very verbose and complex and difficult to read and maintain for huge projects. That's why there is another solution in AWS to build infrastructure as code, which is my favorite one. And I am talking about the Cloud Development Kit, or the CDK. Okay my people, so let's get started with this project of infrastructure as code. As you can see, we are already seeing the same diagram we saw in the video in the last episode of this channel, where I explained to you how to build an auto-scaling group in AWS pretty easy. And now I am going to show you the same system but described with the Cloud Development Kit, or with the CDK, which allows us to describe infrastructure with code. And particularly I'm gonna use TypeScript for the programming language for the CDK. The CDK supports many programming languages, not only TypeScript, also JavaScript, I mean Python, Java and others, but TypeScript, I think it's the most propagated or well supported language as far as I know. And I'm gonna show you how to describe this system with code, pretty easy. But I want to clarify, the Elastic Container Registry is not part of the infra's code in this example. I think you can also describe an easier image with code, but I didn't do that in this example. I'm just pulling the existing image. You can do it if you want. And there are also hidden elements that are not shown in this diagram, like the VPC, the Virtual Private Cloud, and the security groups, but they are also, I'm also gonna show you right away that in my project. So this is how a typical CDK project looks like. You first have to make sure you have the CDK already installed. You can verify that by writing CDK version. I have the version 2.1. There's also an unstable version 1.x. I don't know, but I recommend you switching to the newer, because I think they are gonna eventually deprecate. They will eventually deprecate the 1.x. I think so. Try to use the 2.x. Well, for starting, you can start from scratch a CDK project. I think there's a command for that. You can look at that in Google. I don't remember it right now, but it's like a CDK init, launch template. There's like a start example or something like that, and you can specify the language. The command looks like this. And then it's gonna create a scaffold or a bootstrap project, very simple project, which you can then work on top of it and edit it as you wish. And the entry point is declared here, where you instantiate this app class from the CDK. You just have to instantiate it, and then you can create your own stack. As you know, CDK works on top of CloudFormation, and that means we also finally produce CloudFormation stacks. You can see your CloudFormation stacks in the AWS console. Here we are watching all my stacks that I've created, but the one we are working with today is this one. It says it is updated completed. I mean, it is already done, it is created, but I can show you an update to the stack later. I'm gonna show you that later, but Look at this. A stack, if you don't know, a CloudFormation stack is just a group of resources, AWS resources, EC2 instances, auto load, load balancers, application load balancers, ECS, and so on. Every resource you can create with AWS mostly is available for it being described with CloudFormation too. You can see the resources here. Of my project, we have an ALB, we have security groups, we have what else? Target groups, more security groups, and so on. And you can also watch the events along the creation. Whenever the creation is going on, you can monitor the status, if it is working. If this didn't work, it is gonna try to do a rollback and all that. But you know already, now you have a clear mind of, or a better perspective now what is stack. Now you can define actually the stack maps one-to-one to a TypeScript class. Yes, as simple as that. You have here a TypeScript class that extends a stack, which is a part of the library, of the CDK library. First of all, I want to show you the package JSON. You can see here the dependency. This is the most important one, the CDK library, which has all these dependencies like the EC2, IAM, auto-scaling, elastic load balancing, and so on. But yeah, so whenever you want to create a stack using CDK for CloudFormation, you just create a JavaScript class and you extend a stack. And then you define the constructor, which has to have, it must be like this. You have first a scope, which defines the scope of your whole app. And then I won't go into very detail because otherwise the video would be very long. But the constructor of a stack looks always like this. First you have the scope, then the ID of this, which is a unique string. It must be unique for this class. And then properties, which is normally an object, and that is an interface, a JavaScript TypeScript interface with the types, what it's expecting as parameters. And then whenever you define the stack, you can create methods. I define methods, one to set up the dependencies of this diagram. As you can see, we have this diagram. So what do we do? What do we need? Auto-scaling groups. They need Linux images, right? Keepers, SSH keepers, what else? Instance type. If you want to create an auto-scaling group or a target group, you have to specify how big or how small should be your instance, and so on. And every detail of that, what I mentioned before, is defined here. And also the user data, the script that is going to be booted in each instance to run the Docker container and boot up the application. You can also specify that here with the user data construct for Linux, and then you just add pretty much a batch script, just like this. And the IAM role, for sure, you need IAM roles in order for these EC2 instances to be able to access to the parameter store, for example, or being able to pull images from the Docker registry, and so on, much more. Yeah. That is pretty much it. And yes, the images, I am pointing to an existing image in my repository. So if you want to clone this repository, you have to make sure to you can either specify another image or create an image with the same name. But it's very important that your AMI Linux image has Docker if you want to replicate this system. Because here we are starting Docker from scratch, but it is already installed in the image, in the operating system. And actually, I am reutilizing an existing VPC, which is my default VPC in my AWS account. Here's a very important point to notice. You could create your own VPC describing it with infrastructure as code as well, but I didn't have enough time for setting up this project, so I did reutilize an existing VPC from my account. But ideally, you want to create everything with infrastructure as code, and also the VPC can be created as in that way too. But yes, you can also reutilize existing resources. This is also useful for you if you don't want to recreate everything from scratch. Yep. Or for example, you could use this you could describe a VPC in another CloudFormation stack and output the ID. You could for example output the ID and then reutilize this output in other stacks. So stacks can output resources so they can be utilized from other stacks, and you use this like reusing components just like code, but at the stack level of the resources. So whenever you set up everything you need, like VPCs, image, instance type, and so on, you can create the target group and then the ALB as well. Because once you have created the target group and the load balancer, you can finally create the autoscaling group. That is like the order actually. So we can describe a target group like this with this construct, application target group, where you describe the instance type, and now you are, you specify here basically that your application target group is gonna be of type instance, because you can also point to IPs and to other elements that I'm not remembering right now, but you can also point to private IPs. And you open the AT port and you specify this VPC, which is the one specified in the setup. And then the health check, this is very important. That is depending how your application works, but for Spring Boot's applications, you have a health check in actuator health. You can rename it, I think, but I left it as the default name, actually. And then you can create an application load balancer like this with this construct, internet facing through. Otherwise you will have a private private application load balancer. And then you can create a listener and point it to your target group, which was defined here, just like this. And this is everything you need to set up an ALB and a target group. Very, very, very easy. And once you're ready with that, you can finally create your auto scaling group. I created, okay, there are many topics to specify now, but first I created an extra security group. I will explain now why do I say extra, but this is an extra security group that opens the port 22 for any AP. I just want to be sure I can SSH to the instances on this scaling group from wherever I want. But this is an extra security group because CDK is so amazing that I didn't have to manually set up the security group for each of these instances created by the autoscaling group. I didn't have to specify for the instance, hey, this instance should be reachable only by the traffic on the ALB, for example. I didn't specify the security group for the ALB. I didn't specify the rules, the inbound rules for the HTTP 80 port for each instance. And that is done automatically by the CDK using the least privilege rule. And that is amazing because it saves us a ton of time. So in order to do that, actually the CDK is gonna do that automatically unless you specify a specific security group here, but as I didn't use it, the CDK is going to provide a default security group for this autoscaling group. And as I attach here, I am attaching this security group to the target group I defined before. It is automatically going to know, okay, every instance belonging to this autoscaling group must have an inbound rule that allows traffic from this target group, which is attached actually to this ALB. And then it makes everything automatically, and that is amazing because those instances are going to be very well secured with these security groups, which are not exposed to the public, only to this ALB. So you have private instance basically, and that is great. And yeah, and you can also specify other parameters in your autoscaling group, like the key name of your key pair. I just hard-coded this. You could hard-code it whatever you like, or just used a input parameter to describe which SSH key do you want to use for your instances. Actually, I don't think it's the best practice to hard code anything, but in this little example, I thought, well, hey, why not? But here, take a look at this. You can set up the min capacity and the max capacity of this auto-scaling group. You can specify the health check. As you remember, auto-scaling groups have the ability or the capability to have two types of health checks: the EC2 health check and an extra optional health check that I recommend to always check also, the ELB's health check, which basically is the elastic load balancer checking directly to the instances, or yeah, it's like an extra check basically, I would say. And you give it a grace period of time of 6 minutes, I mean, because sometimes your instances can take longer to boot. That is depending on how many things are you doing in your user data. Actually, that is pretty quick, I would say. So I gave it 6 minutes just because I wanted to exaggerate a little bit, but it could be easily 4 or 3 in this example. I just wanted to be on the safe side and give it 6 minutes. And that is basically, after the creation, specifying the description of the auto-scaling group, this stacks is basically done. And now I'm gonna play with some commands of the CDK, like CDK synth. You know what is the output of this command? This is going to output a CloudFormation template, which is actually what AWS understands. Look at this. This is the CloudFormation syntax, and it is a very, very long template. So you can appreciate how many lines of code do we spare or do we save using a programming language like TypeScript and using the CDK instead of doing everything directly in CloudFormation. We can save a ton of time, tons of times. That is amazing. The other thing I wanted to show you is this command CDK diff, which actually compares the current status of our CloudFormation stack deployed to AWS, the one we got here, and the actual changes that we did in the code. And there are no differences, but what happens if I want to scale up this auto-scaling group? For example, I want to increase the minimum capacity to 2 and the desired capacity to 2. I could do that, and then I can run a CDK diff again. And I should expect that there are changes now, which actually these changes are not automatically applied unless I deploy this again. And well, I'm gonna scroll this a little bit up because I think the webcam is like, okay, maybe you cannot see this right now, but yeah, the desired capacity was increased, and I'm seeing a diff here. It's so sad that that cannot be shown yet now because of my webcam, but yeah, I can see a difference and it was increased. And I can actually deploy this so you can see in action how can we change hardware or services in our AWS system just doing a little change in the infrastructure as code description. So I can, in order to deploy this, it's very easy. I just write CDK deploy. Now I have to wait a little bit, but in the meantime I'm gonna show you this. So this is CloudFormation actually, and I have a lot of stacks which were experiments, but this is the one we have right now. And in a short while we should see an update in progress. And now here it is doing a calculation of what is going to actually be changed and what is going to remain like this. So I see here update in progress. Okay, maybe I can show it like this so you can see it better. You can see this right here. Okay, so you see we have 0 of 3 steps and we are in an update in progress, just like here. This output console should show the same status that we are seeing here in the AWS console because it's the same thing. and I see here now that it is in progress, and I can see also the events, which are the same events that I should be seeing here, but here I don't see so much detail, but here I see everything detailed. So for example, the automatic scaling group is going in an updating progress. It's everything going to be updated, and if I go to my auto scaling group in the EC2 dashboard, which is here, I think, or here, let's go to the auto scaling groups. I should see actually the updated amount of 2 now. I see desired capacity 2. That means my changes were already applied to the auto scaling group, and I should see an increase of instances here. I should be, yes, as you see here initializing in this instance. This was on the already running instance, which is working. You can see here, I can here refresh, and you see only one IP because only one has been registered right now. But if we go to our target group now, we should see one healthy instance and one instance that is going to be initialized. And that is very simple. That happens because we actually updated the desired amount of instances in our auto scaling group manually. Remember that we can set also a tracking policy, an auto scaling policy like this, but we didn't specify an auto scaling policy in this example, but we could create one also using infrastructure as code. I just wanted you to know this. I didn't use it in this case, but you can use create a dynamic scaling policy based on CPU usage, memory usage, or network in or network out or request count, whatever. Yes, and now in a matter of minutes, this instance should be already registered in the target group. Yes, both are healthy. So now if I refresh this URL, I should see that the load balancer is now sending the request to 2 IPs. Yes, I am pressing the F5 button, so I am refreshing and sending a new request from time to time, and now you can see the load balancer has 2 instances registered, and that means the CloudFormation stack should be already in update complete, as you can see. So we updated our AWS services, our diagram. We did an update without doing manually changes. I didn't go to the auto scaling group and click edit and change here manually. No, I did it using our project, our code, our infrastructure as code change. And that is very, very, very powerful because we are tracking every change that we are doing to this code with Git. As you can see, Git status, I see I committed something, I did a change, and now I have to commit it. And now every guy that has access to this repository is going to know what is the current state of this infrastructure. And that is very, very powerful. And it is also very powerful to detect if we did anything wrong, to detect changes that didn't have to happen. We can roll back easily and so on. So my people, that was the video of today. It was shorter than expected, but I just wanted to show to you how cool can be infrastructure as code. And believe me, this is just the top of the iceberg. This was a very, very simple example, but you can create modules, libraries, export libraries to others, so you can reutilize a lot of systems from others. There are templates of CDKs, CDK projects available in the website, in the internet, I mean. There is a lot going on here, really. There's a lot going on. But yeah, so anytime you got to create a system using AWS resources, and you want to monitor them, to have tracking history of changes and so on, and you want to replicate the system easily for testing environments or whatever, I recommend you using infrastructure as code. And why not using the CDK, but you have other options. If you want, you can use Terraform or serverless framework and others. That's all. If you like this kind of content, smash the like button. Don't forget to subscribe if you're new to this channel. I am uploading content like this every week. I am working on my English pronunciation, but any suggestion, please, are welcome. You can write anything in the commentaries, in the commentary box below. And yes, that's all for it. I see you in the next week. Nos vemos en la próxima semana.